This is the world's first Metamorphosis quiz. Check this out. How much mass can a star lose? A little bit. B, half. C, most mass. D, nearly all. Or E, all of its mass. Well, in this theory, a star can lose all of its mass because it's recycled back into other stars. Of course, there are different events that allow it to lose a little bit, half, most of its mass, and nearly all. But how much mass can it lose? It can lose all of it. What conservation law contradicts accepted stellar evolution theory? Conservation of mass, conservation of energy, or conservation of angular momentum? D, all of the above. Modern stellar evolution theory ignores most conservation laws because it was invented by people who didn't have all the information available at the time. 3. Is mass the only variable required to determine the future fate of a star? That is an emphatic no. It is a variable, but it is not the only variable. Inside of mainstream astronomy, mass is the only variable to determine the future fate of a star, which is completely false. We know this because of other reasons. I'm not going to go over them now. They're in the quiz too. Do stars evolve greatly to the point of no longer shining? Yes, of course they do. They evolve by huge amounts, and they do eventually stop shining. We know this because we see how they evolve stars, and sometimes we can't see them, and the reason why we can't see them is because they no longer shine. They don't have any huge plasmatic atmospheres like the sun does now. As a rule of thumb, how can the youth of a star be determined? A, the intensity of light emitted. B, the mass. C, if it can form chemical bonds. Or D, all of the above. All of the above. Youthful stars have very, 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 very intense light. We're talking X-rays and gamma rays. A good example would be Sirius B, the white dwarf. That emits very strongly in the UV spectrum, and I believe in the X-ray spectrum as well. The mass. Very massive stars are very young. They have yet to lose their mass, and the old stars are a lot less massive. They have lost all their mass as they evolved. And see if it can form chemical bonds. The most evolved stars can form chemical bonds. We know what those are. We are literally made of lots of chemical bonds, and rocks and minerals, things like that. If it's too hot, too youthful, the bonds won't form. They'll break apart as soon as they're made. Really young, hot stars can't form chemicals, but as the star evolves, the chemicals can form because the star cools down enough for those chemicals to form. So it's a good rule of thumb to keep that in mind. The most evolved stars will have lots of chemicals in them. 6. Can education deceive students' accuracy, or scientists' accuracy and validity of future work? A, yes, some education can deceive. B, no, all education is valid and accurate. C, it is a mix. Hard science education is always valid and accurate, but soft science and humanities education can deceive. Hard science, let's go over number C. Hard science education is always valid and accurate. That's false. Hard science has a long history of being invalid and inaccurate. So that's one of the surest things we have on this table that's not correct. So it can't be C. And B is obviously incorrect because saying all education is valid and accurate, that's just completely bogus. When you go to school and learn things, you might be learning lots of invalid and inaccurate information. And you always have to keep that in mind when you're getting an education. And we should remind our students of that. All right. 7. Is misinterpreting evidence possible in science? Of course it's possible. They misinterpret evidence all the time. Does the solar system have stars vastly different ages? Yes. A little bit of explanation on that. The sun being the youngest, and all the way down the line, Jupiter, Saturn, Uranus, Neptune. I say Uranus is probably a bit older than Neptune because, well, various reasons. One of them being it's less massive, two being its magnetic field is weaker. Magnetic field evolves as the star evolves. Well, I'll go into that later. Number 9, which element mainly forms the inner cores of life-hosting stars? A, helium, B, carbon, C, iron, D, gold, E, osmium. Well, clearly it's iron, and we know it's iron because of iron-nickel meteorites. Those are the cores of smashed-up remains of stars, and those enter in the atmospheres of other stars and reform the core. They're recycled. But of course there's osmium and gold in there too, and maybe some carbon, maybe some helium that gets bonded. But those are mostly trace amounts, parts per million, parts per billion inside of that. Of course I should have put nickel here too, but iron is good enough. The iron makes the core of ancient, highly evolved stars that are hosting life. 10, last but not least. What is the oldest classical planet in our solar system? Out of the original 9, so we're talking Mercury, Venus, Earth, Mars, Jupiter, Saturn. A, it's Mars, B, it's Neptune, C is Earth, D is Mercury, E is Venus. I'm saying it's Mercury, mainly because Mercury's core is about the same size as Earth, which means it had to have been about the same size as Earth to recycle all that core material there. Only Mercury is peculiar because it's had its outer layers of its mantle completely torn apart and ripped apart and shredded. And to dig into Mercury's inner regions that far would have to have placed Mercury as a very, 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 very old object. As well, it should be evident because Mercury's surface is pitted with numerous impact craters all over its surface, all over the place. It's a completely dead world, and it's been dead for a very, very, very long time. Much, much, much longer than Venus, Earth, Neptune, and Mars. But if I had to go their ages, just by looking at them, by trying to think it through, Neptune is clearly the youngest one. I would say Earth is really, really freaking old. And then you would have Venus and Mars, which are, I'd say at least, Mars at least maybe 15 to 17 billion years old. I don't know, I have it written down somewhere. And Venus at least 25 billion years old. And I say Venus is a bit older because it's larger, it had more time to form. It's almost the size of Earth. And 2, it still has a lot of carbon dioxide left over. Mars's carbon dioxide is almost completely vanished on the surface. And it's basically another dead world. I don't know if anybody's following Elon Musk's plan to go to Mars, but I don't think it's very wise to do that. It's not the future of humanity. We're not supposed to go to a dead world and make it our home. We're supposed to ignore it and find a home that's actually suitable for us. It's not our future. If anything, we'll probably build huge spaceships and live on those for a while as we go from star system to star system. But Mars, no way, Jose. All right, you guys, I just thought I'd share this first quiz with you. I don't know where this idea came from to do this. I guess I've been in school my entire life and thought it'd be fun to do a little multiple choice thing here so people can understand what's going on here. I'm essentially a teacher now, and it feels really weird. All right, you guys, today is February 25th, 2019.